So let's begin. First of all, McGraw-Hill welcomes all the attendees and our honored speaker for joining us today on the webinar, Why Python is Great for Machine Learning. Our speaker, Anurag Gupta, is an IPS officer who has recently authored a book on Python programming published by McGraw-Hill. He's an avid writer for Open Source for You magazine and has contributed multiple articles on Python projects, which are also available on his GitHub page for anytime viewing. I think he would love to share them with you with due course of the session. Today, he's here to share with us his views and insights on machine learning, skills required for machine learning, and brief introduction to the concepts revolving around Python programming language. Let's hear more from our speaker. Stay tuned to enjoy the session. Over to you, sir.
Thank you very much, Prakriti, and I thank all of you for taking out the time to listen to me. And I must admit in the beginning, I am not an academician. I am an engineer, but my profession is police. And in the policing work, we had to deal with a lot of cybercrime issues. So we were looking for a tool which could, give us deeper insights into cybercrimes. And I found Python to be a really a great tool. So we decided to follow it up, and today I've written a book on Python. I must tell you the basic philosophy which I have followed is that if a student cannot understand a concept well, then probably the teacher also has to look at his own style of teaching and see whether the problem is in the student or in the teacher. The point I'm trying to make is that I think anything, given the human brain and the mind is a vast, capabilities, anybody can learn a programming language like Python. And I would especially like to welcome people from humanities and arts and medicine and biotechnology and physics and astrophysics and say to them that Python is such an easy language that any one of you, all of you can learn Python. Python has great libraries for biology, for physics, for chemistry, for astrophysics, for geography, for data science. So that's the way I would like to start. So let me first start with this, what I would like to call the Python world. So Python, the beauty of Python is it's like a Swiss knife. So you know what a Swiss knife is. It has one small tool has everything. So the beauty of Python is that it has so many libraries, thousands of libraries that you can do anything with it. You can do number crunching, you can do programming, you can download data, you can use it for APIs, you can use it for mapping, you can use it for data science, and so many other things. So that's why I encourage all of you should learn Python, irrespective of whether you're going into data science or not, even if you're going into any humanities subject, if you're doing any research work. So, for example, if you want to do any statistical analysis, earlier people used to depend on a library called MATLAB, which is a paid software. So today Python can do anything and everything which MATLAB can do and much more. Similarly, I know many, some of you who are, who have done their research work maybe 10 years back. So they might have relied on a package called R, which is great for statistical analysis. But today, I think Python has beaten R, and R is on the decline, and Python is on the rise. So if you want to create websites, the backends, you have packages and frameworks for that. That is why I feel Python is such a great idea. About me, Prakriti has very kindly introduced me. I am an IPS officer. I did my engineering from Chandigarh, Punjab Engineering College, and but I must admit and confess that in my entire engineering courses, which of course were so many 3 decades back, we used to study C++ because Java was not really that popular in those days, and I found C++ to be extremely difficult language. I like to give an example, because I feel computer science is a very abstract subject, and if there are any teachers out there, I would like to suggest to them that whenever you talk about computer science, try to speak in terms of analogies. So one common question which people ask me is that, is Python powerful? Now, I would like to answer that question in this way that suppose you need to go to the market to buy a burger, right? So you could go on a bike, you could go on a car, you could go on a truck. And a truck is certainly much more powerful than a car or even a bike. But Do you really need a truck to go and buy a burger? So obvious answer is no. So the point I'm trying to make is that if you want to buy a burger, then use a bike, don't use a truck. Yeah, but if you want to carry your household stuff to another city, then maybe you can use a truck. The point I'm saying is that Python is great for certain areas, it is great for certain applications, but of course, it is not one vehicle which can serve every purpose in any purpose. That much one should understand. So, if you're going into writing compilers, if you're going into writing applications with thousands and thousands of lines of code, then probably you should be looking into a more statically typed language like Java or C++. Or, but if you are doing a small data science project, not that Python cannot be used for big projects, but if you are going for something which is relatively small, then Python is a good idea. Now, on this slide, I have put some articles which have been written by me. All of them are available on my GitHub page. Some of them are very popular. For example, I wrote an article on what is called duck typing in Python. It was put on an online magazine called opensource.com, and I was told by their New Zealand engineer that it had 40,000 hits. So everything is available on GitHub. In case you can't find it, just type on Google, type GitHub and 999 Anurag Gupta. I think you should be able to reach my web page, right? So let's move ahead and yeah, this is my book. Oh, I must tell you, I'm very well placed in my service, and I don't need to. I don't live off a book. The idea of writing a book was not to encourage any sales or anything like that. It's simply because in police you get so many things, but you miss out intellectual stimulation. So for me, writing this book has been more of an intellectual stimulation, and I encourage you to have a look at the book because this book is very different from a normal book. So what I have done is I've written the chapter, then I've written certain questions, then I have written a topic called beyond text. So I know that in every class, in every group, there are certain students who are more curious than the others. They would like to go beyond the normal, right? So for those kids and for those people, I have written this book in which in almost every chapter there's a topic called beyond text. So if your syllabus says, for example, regular expressions, then I have a topic on look ahead and look behind expressions. So if you see that, you will know. Another thing about my book is that the book was getting rather thick, so we decided, me and McGraw-Hill, we took that 20 chapters are in the form of the book, which you can buy. The other 5 chapters are totally free. So these have some very good chapters. For example, using online libraries. Then there is a chapter on natural language processing. So natural language processing, NLTK, if you have heard of NLTK, the chapter is there. Then there's a chapter on what is called the mapping applications. So the base maps and Cartopy and Leaflet and Folium. These are the Python libraries which are discussed in great details in these chapters. All these chapters are available on the McGraw-Hill website. They're also available on my GitHub page, and you can download those chapters, read them. You don't have to spend any money for that. In fact, there's a chapter on a topic called GenSim. GenSim is a beautiful library for a natural topic, what is called topic modeling. So you can do that. So let's move ahead. And yeah, in this talk, I would like to discuss a little bit about machine learning. And through the one very famous and very popular library of Python called scikit-learn. So, but my book doesn't cover scikit-learn because my book is not about machine learning per se. My book will take you right to the doorsteps of machine learning. So all the skills which you require for going deeper into scikit-learn, all those skills are there. So if you read my book, you should be able to do that. Then I'll talk about some basic skills which are desirable for machine learning. Then I'll talk about there's a brief introduction to open source movement. I feel that every data scientist and every engineer and everybody who uses any form of online material should know about what is open source movement, because many a times when we just do an EULA, that is end user license agreement, we don't really read the contents, we don't really know what we are committing with our data. One thing all of us should remember is that open source movement is about open source software, but today the open source data has become even more important. For example, all of us use Google Maps, right? So when you use Google Maps, you are putting in a lot of data on the map. For example, you might visit a hotel and you find the hotel to be serving good food, and you might give its location on map. So that data becomes the property of a private company, of an entity. So I encourage that people like us, in our country, in India, we should use things like OpenStreetMap. So I don't know how many of you have heard of OpenStreetMap, but in case you haven't heard about it, look at do a Google on OpenStreetMap, and in fact, Python has got some great libraries where you can download OpenStreetMap data. For example, if you're in a city and you want to know the locations of all the ATMs in your vicinity, you can do a search on OpenStreetMaps and download their locations and plot them on a map. You could do this with school buildings, with hotels, with restaurants, and so many other things. Then I'll talk about why Python is a popular programming language, and the positives and the negatives of Python. Then I will also see Python is not the beginning all and the end all. Some new languages are also coming in they are on the horizon. So I would like to talk about them. This is especially true important for those people who are trying to make a career in computer science. So they should know what are the new options. Then I would like to talk a little bit about the basics of Python. And I would like to talk especially about Jupyter Notebooks and Anaconda. I don't know how many of you use Jupyter Notebook and Anaconda, but frankly, if you are all aware, Python has now been introduced as almost as a compulsory subject in the 11th and the 12th of the CBSE board exams, and it is replacing C++ and Java. So, but when I saw the books, I found that most of the books don't talk about Jupyter Notebooks and Anaconda distribution. So, any one of you who is really serious about Python should have a look at Jupyter Notebooks. I'll talk about that. I'll try to talk about NumPy and SkyPy, the two basic libraries for number crunching, which are required for any decent machine learning task. I'll talk about pandas. Then I'll talk about vector space model and Jensen if I get a chance, and GitHub and open source movement. I think I mentioned it twice. So this is what I will do. So let's start. What is machine learning? See, mine is not. This is not going to be a very academic talk. So I'll just give you what I could find on the net. I'm sure that many of these things you can also find on your own. So basically, computer algorithms that improve automatically through experience. So it's very interesting. It's very important. The words. It's basically, so ultimately, machine learning is nothing but an algorithm which automatically improves through experience. That means that just like a human being, when you are riding a bicycle, the more you ride or drive a car, the more you drive, the better you become. The same thing is with machine learning algorithms. In fact, if you notice, I don't know how many of you use Google Docs. Google Doc has an option of where you can, speech to text. Now, you might have noticed that when Google Docs started about maybe 3, 4, 5 years back, the algorithms were not so good. But with every passing day, the algorithms are becoming better. The reason is that these algorithms are being exposed to a vast number of people, different types of speakers from different parts of the world. And so they are able to decipher the different accents and all that. That is why the more they are taught, the more they learn and the better they become. And machine learning is also a subset of artificial intelligence. I'll just talk about that. So, a couple of years back, 20 years back, when the idea of machine learning was just evolving, so there we had applications like email filtering and computer vision. So, there also we were using machine learning, though it was not that popular in those days, but now it is becoming much more popular. Yeah. So there are these three terms which students find very confusing: artificial intelligence, machine learning, and deep learning. So basically, artificial intelligence is the superset, machine learning is a subset, and you can say deep learning is a part of machine learning. So you can say that machine learning, all that is deep learning is also machine learning, but all that is machine learning may not be deep learning. That is the difference. And I'll just try to give you a, yeah. Now let's talk about deep learning versus machine learning. So I have put 1, 2, 3, 4, 5, 6 points. First is relationship. As I have already shown you in the previous diagram, that machine learning is a subset of artificial learning and deep learning is a subset of machine learning. Then problem solving approach. In machine learning, you try to break the problems into smaller parts and then to solve the problem. So basically, machine learning would work in an area where the problem can be more easily predefined, whereas a deep learning project would be where the problem as a whole is given and there may not be any obvious solutions in the beginning. And then, in machine learning, there's human intervention of sorts. For example, feature extraction. Now, feature extraction is a very interesting concept. I've dealt it in my book also. You know, if you deal with vectors, if you deal with vector space, if you deal with languages as a vector, then a vector may have hundreds or thousands of dimensions. So this huge dimensionality of data creates a lot of, makes the data difficult to interpret. So to extract the important features from the data, that is something which deep learning does very well, whereas machine learning, it may not be possible. So if you already know the features you need to extract from the data, then you probably want to go for a ML algorithm. But if you don't know the kind of features which you need to extract from the data, then you probably need to go for a DL or a deep learning algorithm. Then machine learning normally requires less amount of data, obviously, because it already knows the features, whereas the deep learning project might require much more amount of data, right? So let me go ahead. Yeah. These were in the beginning, as I said, optical character recognition. Now, you all know that we have so many OCR softwares. If you give it a picture of a letter, say a letter A or a B or a C, then it is able to say that it's an A or a B or a C. Now, for a printed A or a printed B, this might be an easy task. But if it is a handwritten text, where A written by one person might, substantially differ from that by another person, this would require some form of machine learning. Then spam filters. Now, spam filters, basically, it's what does it do? It is a classifier. When I say a classifier, means that it divides the emails into two categories, whether it's a normal email or whether it's a spam mail. So this is also a machine learning task which was being done earlier. Okay, if you look at the machine learning tasks, basically you can divide into three broad categories: supervised, unsupervised, and reinforcement learning. I'll just try to explain the next slide. Yeah, if you look at this, the first slide shows what is the supervised learning, the second one shows unsupervised learning, and the third one shows what is reinforcement learning. So if you don't know the difference, then the first and the third might look very similar because both of them seem to have a critic which gives a feedback. So basically, when you're driving a car, so your eyes are giving you the feedback and your hands are controlling the car. So it's a kind of a supervised task where if you go wrong, then your eyes can see that there's another car ahead and you brake. So that feedback is constantly being given to you by your eyes, and that is your supervised learning. So a supervised algorithm also where you have a set of input and a set of output. So based on the input and the output, you try to then create an algorithm which will be able to predict the outputs for those inputs for which outputs are not known. So that would be a supervised learning. Unsupervised learning, on the other hand, is where you do not have the outputs and you simply have the inputs and you try to form some kind of an output without knowing whether the outputs you are getting are correct or not correct. That would be an unsupervised task. Now, reinforcement learning is very similar to supervised learning. The difference is that in supervised learning, for example, while you're driving, every time you go even 1 foot off the road, your eyes will tell you that you are going and you can correct it instantaneously. The reinforcement learning, on the other hand, is where the end result will be there. For example, suppose a psychologist trains a mouse to run through a maze, and it has got five different problems. So if the mouse ends up in the right box, then he will be rewarded with maybe a peanut, right? So that is the reinforcement. So he will not know whether he has gone wrong in the process. But if at the end of the task he ends up in the right box and gets a peanut, then he knows that whatever task he has done is the correct task. So the difference is that in supervised learning, the feedback is continuous and constant, whereas in unsupervised learning, the feedback is not continuous, but it will happen only if the task is done right. So if a task is consisting of a number of subtasks, in supervised learning, after every subtask, the feedback would be given to the person who's doing the task on whether he's doing it right or wrong. But in reinforcement learning, if he does the sub processes wrong, he will not know it. He will only know at the end of the task that whether he was able to do the task right or wrong. I hope I have explained that. Let's move ahead. This I already explained. I'll skip this. Yeah. Now, supervised learning can be divided into two broad groups: classification and regression. Classification can also be called as labeling. For example, in a spam detection software, we label each mail as a good mail or a spam mail. So we put a tag. So it's a classification or a tagging. Regression, on the other hand, would be a continuous. So classification would be some kind of a discrete data, or groups or classes, whereas regression would be continuous data. For example, if you look at the Skykit library, so they have a data set on the size of the house in terms of its area vis-a-vis its cost. So as we all know that as the size of the house increases, the cost should also go up, but it may not go up in a linear fashion, in the sense that if from 400 square feet you go to 800 square feet, the cost might double from say 100 rupees to 200 rupees. But when you go from 800 to 1600, it may not double. So the relationship may not be an exact straight line or exact this thing. So having got this kind of a problem, and if you're given a particular area, suppose you're given the size of the house and the price of the house of a particular city, and you're asked to predict the price of a particular size which is not given in your data set, that would be a problem of regression, right? So I hope that this difference between classification and regression is clear to all of you. Yeah. You see, now this is not a talk on algorithms ultimately, because that is a complete subject in itself. So, but classification algorithms are basically can be divided into these 7 types: logistic regression, k-nearest neighbors, support vector machine, kernel SVM, naive Bayes, decision tree classification, and random forest classification. So, scikit-learn has got inbuilt functions to do all these algorithms. Now, one very interesting question which many people ask is that how much of mathematics should one know to do machine learning. So to that again, I would like to give an answer with an analogy. Suppose you want to drive a car, right? Then you just need to know the user interface of the car. That means you need to know the steering wheel, you need to know the brakes, the accelerator, and the clutch, and maybe a few other things. And beyond, you don't care whether it's a diesel car or a petrol car. You don't care whether it has a 4-stroke engine or a 6-stroke engine, whether it runs on some technology or some other technology. So for you, the user interface is the only thing which matters. So that is one level of abstraction. The other level of abstraction could be that you are a mechanic, you are a car mechanic, and you want to be able to repair, some minor faults. Then you need to know some more intricate details about the car, right? And of course, you could go to even a deeper level. Suppose you are a car producer or a car designer, then you may need to know the capacity of the engine, the time it takes to brake, and the fuel to be used, and the temperature at which it will work, and those things. The point I'm trying to make is that if you use inbuilt libraries of Python like scikit-learn, like pandas, like keras, like pytorch, it is very easy to just use the functions or the classes available in a very without knowing the details. So, and you can work. That is okay. So this should be fine for somebody who is simply wanting to use the libraries without knowing too much details. However, if you are really if you're going into hardcore computer science, if you're going into hardcore data science, data interpretation, then you may like to know the parameters which can change the values. For example, how big a data set to use, what fraction for learning, what fraction for testing, what kind of data to use, how to extract the features. So those things you can do. And if you are writing a library, then of course you need to go into much greater details. The point I'm making is that Python provides you the tools and the wherewithals for all the three levels of abstraction. So if you just want to use it, Python has the solution for you. If you want to go deeper into it, Python has the solution for you. And if you want to write your own libraries also, Python has got the solution for you. In fact, the best thing about Python, is it's a interpreted language. Now, interpreted language, I will talk about that if I get time. Interpreted languages are those languages where there is no compiler, in the sense that it starts from the source code and straight away executes. Unlike libraries like C++ and Java, where from the source code you have a byte code and the byte code then runs. The advantage of creating the byte code is number one, if there are any major errors in the program, then the compiler should be able to catch them. Number one. The other thing is that it becomes faster because byte codes run faster than source code, right? But there's a downside to it. The biggest downside, the one which I found in my learning experience of Python, was that when I used a C++ library, it is like if I get a C++ library, I cannot read the source code. In fact, people go to great till at least a couple of years back. People used to go to a great length to keep the source code a secret. So if I have a function for doing a logistic regression in C++, and I want to know how the function actually works, there is no way I can do it, because even if the library is available on my computer, it will be in a compiled form, and it becomes very difficult to read that data. On the other hand, in the advantage of Python is that you can almost read all the libraries of Python, the source code, and understand them and modify them and see them. In fact, in one of my chapters, in one of my books, I have tried to the online chapters. If you see the chapters on GenSim and the natural language processing, the chapters which I mentioned earlier, which are available online, I have tried to discuss the source code and how to read source code. So I feel that that's another great advantage of learning Python, is that if you want to go deeper into the under the hood, if you want to go and see how the functions or the classes work, you can do it in Python, right? Let me move ahead. Then these are the regression algorithms. I explained what is regression. So linear regression, multiple linear regression, polynomial regression, and support vector regression. All these things you can read them for yourself. I will not go into details. Yeah. Now in this slide, I have tried to give the difference between classification and regression. I have already explained the concept broadly. The slide is there. You can refer to it because I would like to move faster. Already 30 minutes are covered. So then, yeah, this is what is called the scikit-learn algorithm cheat sheet. So you might have noticed that I talked about classification and regression, but it has got four broad groups, which is classification, regression, clustering, and dimensionality reduction. So these are the four broad groups in which the scikit-learn algorithms are classified. So once you have an if you know the kind of task you want to do in machine learning, if you're looking for clustering, then these are the algorithms available. If you're looking for regression, then it has got algorithm for that, or rather the classes and the functions for that. If you're looking for clustering, then it has got for that. If you're looking for dimensionality reduction, it is looking for that. In fact, In my book, I have, in the chapter on NumPy and Skype, I have covered one topic called SVD. That is, you can have a look at that, and I think it's great way of, because the problem in books on Python and machine learning is that either you go for a book on programming which doesn't talk about the mathematics behind it or the logic behind it, or you go for a book on mathematics which doesn't talk about the programming behind it. Right? So the challenge for me when I wrote my book was how to write a book and how to explain certain, for example, eigen decomposition. Now, if I don't know how many of you have heard of eigen decomposition, but in my book I've tried to cover this topic of eigen decomposition in a very intuitive manner. I can give an example. The example I gave in my book. For example, suppose you have a globe. Suppose you have a globe and you rotate it by a small angle. Now, every point on the globe would change, right? Except the points which are on the axis of the globe. So eigen decomposition and eigen values and eigen vectors are something similar to that. I have tried to explain that. So you can have a look, or you can read up on the net also. There are a lot of articles available. I'm not saying you have to read on my book, but these basic things, if you understand the concept behind it, the objective behind it, you need not know the mathematics behind it. But if you know that what is eigen decomposition in simple language, then probably you can do what is called single value decomposition and dimensional reduction and all those things, right? Then scikit-learn, it is based on a number of other libraries called NumPy, SkyPy, Matplotlib, IPython, SymPy, Pandas. I'll talk about some of them. In my book, I have covered NumPy and SkyPy. Matplotlib is covered. It is there in the online chapter. So NumPy and SkyPy are there in those. As I mentioned, the first 20 chapters are in the print form. So NumPy and SkyPy are there in chapter number 19 of that of my book. And but Matplotlib is there on the online chapter, which is free. You can just download it. It is chapter number 21, I think, or maybe 22. So that is available on the McGraw-Hill website. You can do that. Then IPython, SymPy is also there in my book. It is the last chapter number 20. But it's a chapter. SymPy is for those people who want to do what is called symbolic computing. I don't know. I mean, when I did my engineering so many years back, all we had was what is called numeric computing. For example, if you want to calculate, say, an integral between two, suppose you want to do integral x square, say from x equal to 1 to x equal to 2. So what you would do is you would divide that area of x square graph from limits 1 to 2 into number of strips, calculate the area of each strip, and then find the answer. So that was a numerical method. But SymPy, on the other hand, does something which is called symbolic computing. So it actually, I mean, you'll be so surprised to see that this library is so good that it can actually compute, integrals of functions like logs, squares, sine, cos, tan, and complicated equations. It can do so many things. So if you are a mathematics student and if you are into symbolic computing, it would really be very intuitive, very informative to read SymPy. And by the way, the entire SymPy library is available online in pure text format. So you can read every line of code, you can execute it, you can modify it, you can change it in whatever way you want. Then Pandas. Pandas also I have covered in my book. It is chapter number 20. And Pandas is great library if you want to project data, if you want to read data. In fact, I have written an article in in a recent in a magazine called Open Source for You recently, which is available in India. And that article does what is called Anscombe's quartets. So that article talks about how data which may have the same statistics may look very different when you project it or when you plot it. And to download the data, I use the Pandas library, which can directly download the tables from a GitHub page. I am not aware of any other programming language which gives you tools to download data of a table directly from a web page, any web page. So I'm not aware. Maybe there are some other libraries also. That's why I think it's a great library. And let me come now. Okay. Let's talk about some basic skills which are desirable in machine learning. So, yeah. I would like to divide this into 3 or 4 parts. First is certain general concepts about programming. There are certain concepts about programming which which you should know, and they are not very difficult. They are difference between scripted and compiled languages, and in fact, I never realized the difference till I started learning Python. Because if you belong to an ecosystem which uses only a language like Java or C++, you would never really know the difference between a scripted and a compiled language. Then difference between a statically typed and a duck typed or a language, and type hints. I have in my book I've given a very nice example which I would like to repeat. What a language like Java or C++, what does it do? Suppose you want to create a variable, say X, and you want to store a particular value, say 5 in it, right? So you have to reserve a part of the memory, and you have to give it a label of X and put a number 5 in it. Now, what happens in a language like Java or C++ is that the box, or let's call that part of memory a box. That box also has a type, and the data it contains also has a type. So there is a type of the label. So if you ask X, what is your type? He will say, I'm an integer, because I'm holding a number 5, which happens to be an integer, right? So therefore, a box which can hold a 5 may not be able to hold a floating point number or a object or something else. This is the way statically typed languages work, right? But this is not the way Python is designed. Python is totally different. Python is, there you can think of the box as not as a box, but as a kind of a tag, something like a price tag. So that same price tag could be put on a shoe, it could be put on a matchbox, it could be put on a suit. So it will indicate the price of that particular object. So now if you ask the price tag in Python, what type are you? So what it will do, it will see the object to which it is tied. Suppose it is tied to an integer, it will say I'm an integer. So if X is equal to 5, then if you ask the type of X, X will say I'm an integer. But if X is equal to 7.9, and if you ask what is the type of X, then it will say I'm a floating point number. So this might appear a very simple thing, but it makes a huge difference, right? So if you but a language like Java will not allow this. So if you have written integer X and then you try to make X equal to 7.9, it probably will create an error. It has a plus point and a minus point. The plus is that the chances of going wrong, the chances of putting float points where you expect integers is less. But the negative is that the language becomes so much more difficult to use and so much more complicated, so much more verbose, so much more cumbersome. So Python is what is called a duck type language. So duck typing, I've written an article on that in one of the open source magazines. The link is there in my opening slide. You can have a look. But let me explain. So I don't care what you are. I just care the way you behave, right? So if I have an object which talks like a duck, which walks like a duck, which acts like a duck, then it's a duck for me in Python, right? So I'm not concerned about its properties, I'm concerned about its behavior. But this is not the way in C++ and Java works. Then there are other things we should know, like passing by value, passing by reference, object-oriented programming, errors, and how to handle them. And I think Python has a great libraries and great way of dealing with all these things. You can have a look at it. Let me go ahead. Yeah. So when you are doing machine learning in Python, these are the 13 things which I could identify, which you should know. There might be more and maybe some less. Installing Python, you should know how to install Python. You should know how to install Jupyter notebooks. And you should be able to use pip if you're using Python, conda if you're using libraries like Jupyter. Then you should be able to understand the concept of virtual environments, because when Python moved from Python 2 to Python 3, there was a huge change in the ecosystem. So virtual environment is very important. You should know about operators in Python. You should know about built-in data types, strings, lists, dictionaries, and tuples, etc. Especially dictionaries, because as you all, those who are into programming would know that in today's world, almost all APIs, they send the data back in the form of JSON strings, right? And Python dictionaries are nothing but JSON strings, so you can use that. Then you should know the basics of functions. Then concept of function arguments, default arguments, position arguments, keyword arguments. These are pretty dense concepts which may confuse a beginner, but I think I've covered them pretty well in my book. Have a look, and I think I've done a good job. Then flow control, conditional statements, then object-oriented programming, inheritance and namespace. These are very important concepts because in a object-oriented programming like Python. Now, by the way, Python you can do multiple inheritance also, which you cannot do in. I think in C++ you can't do multiple inheritance. That means that if you have a class called say cat, and you want to create another class say house cat, you can do that, but you cannot create a subclass from 2 or 3 different parent classes. You can do it in Python. Then you should know file operations, you should know Python exceptions. So I think that about 1 semester of study should be able to bring you to the desired level of competence to deal with all these 13 topics, and you are on your way to machine learning. So if you are into machine learning and you can skip some of these topics also, but if you do these 13 topics, then by and large you are good, and you should not have any problem in dealing with machine learning, provided you understand the algorithms and the mathematics behind it, in case you want to go deeper into it. And you can skip the mathematics if you don't want to know the mathematics, but just use those algorithms. Yeah, these are some of the common terms in machine learning: ML algorithms, modeling, difference between algorithm and a model, mean squared error, minimizing the cost function, gradient descent, anomalies, overfitting and underfitting, accuracy of the model, then true positives, false positives, true negatives, false negatives, and testing and training splitting of the data. So these are some of the concepts. I can't obviously go into the details because it's a very detailed subject, but if you have this slide in front of you when you're studying machine learning, I hope it will help you to go on the right track, right? So a typical machine learning task would be you install the libraries, then you get a data set. By the way, I hope all of you, those who are into hardcore computer science, I hope all of you are using GitHub, because it's a great source of data. And if you want to do any meaningful machine learning task, you need to have data. I can give an example. I remember I saw, I think that website is called 538. So if you do a Google on 538 GitHub, you should land up on a beautiful website. In fact, what happened was in 2016, when the US elections were taking place, then there was an allegation that certain Russian trolls, they tried to influence the elections, and by sending out tweets. So almost 3 million tweets were then submitted to the, I think, American Congress by the Twitter company, and all those tweets are available in the open domain. So and you can do sentiment analysis, you can do clustering, you can do classification, you can do text analysis. So such kind of data is available on GitHub. So if you are an aspiring data scientist, then GitHub is a great place for data, and you can get different types of data, and you can actually test out your all your algorithms and your machine learning programs on that, right? So these are the tasks which you can do for a typical this thing. Let me move ahead. Yeah. Now, there are so many Python libraries, it's not possible to talk about them, but I would like to divide the machine learning task into 2 parts. That is the hardcore libraries for machine learning, which is given down here. That is NumPy, SciPy, scikit-learn, Pandas, Theano, etc., and certain libraries for visualization. I feel that any aspiring data scientist should actually know data visualization very well, because if you are into any kind of research work or any kind of data presentation, then you need to be able to present your data for to be able to interpret your results, to be able to show your results to other people, and Python is a great ecosystem for that. And I've given the names of 5 such libraries. In fact, this Plotly is such a great library. I will show you one script which runs on Plotly if I get the time. It's a Canadian company, and it's a group. It's a great library. So these are libraries you can see. you know, why Python is such a popular language. Now, if you do a stack, I hope all of you are using Stack Overflow. In case you're not using, you should be using it, because uh, if you have any question about any aspect of computer science, Python programming, or any programming for that matter, the chances are that the answer to that question already exists on GitHub, on Stack Overflow. So Stack Overflow every year they do a survey of the popular programming languages, and you can see Python is very high in that. The only three languages which are above Python are JavaScript, HTML, and then this SQL. So JavaScript is very popular, obviously, because JavaScript is the language of the browser, and you cannot do anything in a browser without JavaScript. But JavaScript is a notoriously difficult language to use, and probably not the right language for machine learning. So then in 2020 also, Python has been very popular. I'll skip this. Okay. Now, why? Because the talk of today is that why Python for machine learning. So, in order to be good for machine learning, it should also be a good programming language. So, it is simple and logical. It is easy to learn. It is one of the easiest languages to learn. In fact, I just took about maybe 3 to 6 months to learn the language. In a very good way. And I think that anybody who puts in a few hours of practice every day and should be able to master the language within 3 to 6 months. And if you have already having experience of another programming language, it should certainly be doable in 3 months. It is scripted and dynamically typed. It is open source and free. It's open source and free. That's a great. I'll talk about open source if I get a chance. It has thousands of libraries. It has a huge community. Having a huge community has two distinct advantages. Number one, if you get stuck, if you have a question, somebody will find an answer for you. And number two, if the community is huge, that means the developmental work is also huge. See, the language, you might have the best programming language in the world, but if you don't have its libraries, if you don't have its ecosystem, if you don't have its users, then that language is useless. On the other hand, if the community is huge, so there's a lot of development happening, then it's a good ecosystem to work on. So whenever you are choosing a framework, choosing a language, choosing an ecosystem for programming, have a look at the community. If the community is vibrant, dynamic, growing, then it's a good language to follow. But if the community is dying, for example, I think Ruby on Rails, for example, Ruby on Rails used to be a great platform maybe 20 years back, but today I think it's a dying language. I think the same is, I mean, I may be wrong, but I think even R is a dying language. So that way you have to see, right? Then programming is good for server-side programming, prototyping, game development, data science, visualization. But it is not good for certain areas. It's not good for scalability. It's not speed. If speed is the issue, then probably Python is not the right tool for you. It is not the. It doesn't have mobile apps development. Then, if you want to do the front end rather than back end, suppose you want to develop web pages or you want to develop browser side scripting, then probably Python is not a good idea. It is not good for multi-threading. Now, multi-threading is an area where Python seriously lags. A lot of efforts have been made, but it's an issue, and it may be difficult to maintain for very large projects. In fact, recently I was reading an article that many of these top companies like I think Facebook and even Twitter, they when they depend upon Python, what they have started doing is something called type hinting. So in Python you can do it. I can't talk about type hinting because it's a complete subject altogether. But they are in Python they are trying to find what is called the middle ground. So one side is static typing, other side is dynamic typing, and in between is what is called type hinting. So you do a Google on type hints in Python and you get the entire this thing, right? And so errors and bugs are difficult to catch. This is not a problem of Python alone. This is a problem of all dynamically typed languages. If you use a dynamic language, if you allow a variable to have anything in it, integer or a floating point or an object, then you have to be very careful because if you add a string to an integer, like in my book I give an example. Suppose you want suppose a number one is a string and number one is an integer. So if you add the integer to a string, if you add a string 1 to a number 1, what should you get? Should you get a string of 1 1? Should you get a number of 1 plus 1 2? What? Now, this is where the problem starts. So if you are in Java or C++, the moment you try to do these kind of things, the moment you try to add a integer to a string, it will not allow. So the problem will be caught there and then. But in a language like Java, in Python, this problem will not be detected. We will only come to know at runtime when you run the program, that the program it cannot run because you cannot add a string to a number. So these are the downsides. So I've mentioned that. I'll skip this. Something about JavaScript. I'll skip JavaScript because that's not my topic. But I've compared Python to JavaScript, and yeah, this is something I'd like to talk about. These are some of the other programming languages: Julia, Go, Rust, Swift, Kotlin, and TypeScript. So TypeScript is nothing but JavaScript with types. So it's a comparatively new this thing, and you can read about it. So TypeScript is supposed to have a good future, and even Rust. Rust also seems to have a good future. So these are the new languages which you might do if you are into hardcore computer science. If you are trying to build a career around programming, then you may like to have some of these newer languages and take a decision whether you would like to follow them up, right? Then I'll skip this. The Zen of Python. No, I would have discussed this had I got more time, but only one or two Zen. Zen of Python is the philosophy of Python. One I would like to mention: explicit is better than implicit. So, so Python says that whatever you do, do it explicitly. Don't do it implicitly, because if you do something implicitly, people may not really know the. In fact, there's another one which I would like to say, that is, if just one sec. It's not mentioned here, but I'm not able to locate. But the point is that code is more often read than written. This is very important. Code is more often read than written. The point is that somebody who writes a library in any language, writes it once. But somebody who's trying to modify it, understand it, reads it many more times. So whenever you write code, the readability, yeah, this is the one, readability counts. So the readability is the most important part of writing code. So a good Python, and in fact, most Python libraries, they have this concept of readability counts. That is why it is so easy to understand Python libraries. And when you write code, you should also take care that you should give comments and all those things, which so that your code becomes more readable. The basics of Python, I would have loved to do this, but I'll skip this. You know, Yeah, Jupyter Notebooks, I've already mentioned. I just like to mention that in case you have not heard of Jupyter Notebooks, it's basically a client server ecosystem. So what happens is that when you download a Jupyter notebook and you run the Jupyter notebooks, it will run a small server. That server can be run on your local machine also. That server can be run on a remote machine also. So, and once that server runs, it will open a web page on your browser, and you are able to then interact. You can write the code in the browser, and you will get the results in the browser. The other advantage of using this Jupyter notebooks is that you can alternate the program with the text. So this is especially useful for those who are teaching computer science. So suppose you want to explain a long program to a class of students, right? So you can break up the program into 5, 6, 7, 10, 15 parts and write each part in a small box. And you can also explain the same concepts in that same presentation. So I can't, explain to you these things in a minute because it will take time. But if you do a search on Google and you do Jupyter notebooks, you will find thousands and thousands of Jupyter notebooks. In fact, there is a website. I'm unable to recall the link, but if you do a search, then beautiful Jupyter notebooks. Do a search, and you will find Jupyter notebooks on everything under the sun. Jupyter notebooks explaining algorithms, Jupyter notebooks explaining astrophysics, Jupyter notebooks explaining, chemistry, physics, astrophysics, geometry, geography, you name it, you have it, right? So I have given the links and you can have a look. I'll skip this. And I'll skip. Yeah. Now I want to come to NumPy and SkyPy again. Because I've already touched 57 minutes and I don't want to go into the depth of programming. It's not possible to teach programming in a session of an hour or so. I will just quickly run through the slides. You can have a look. I hope Prakriti will make the entire presentation available to all the participants. And my email ID is there, and if any one of you wants to come back to me on any issue, I would be very happy to answer questions on NumPy. And then this is dimensions in NumPy. Then I'll just skip through these. Then broadcasting in NumPy. These are the things which are there in the book. You can have a look, and some examples are there also. Then a lot of topics are covered, and you'll be surprised that so much of knowledge has been packed in about 500 odd pages. In fact, this solving linear system of equations is something which you can do with NumPy very well. Have a look at it. I can't explain in the short time I have, but have a look. Then I have tried to explain briefly the concept of matrices and vectors. It's a very simple concept, but it makes people so scared of mathematics, the vectors and matrices. I've tried to explain in my book, multiplying a matrix by a vector and all those things. Then I've talked about these things. And then, this is the slide on eigenvalue and eigen decomposition. Have a look at this. I think because I did a lot of research to write this particular topic in my book. So, about eigenvalues and eigen decomposition, eigenvectors. If you don't understand these concepts and read my book, I think it should help you. Yeah, and then eigen decomposition. Then I'll move ahead. So what I've done in this thing is I've taken a real world example of eigenvalue and eigen decomposition. And first I've done it without using a library. And then I've done the same problem using using NumPy. So when you compare the two approaches, you probably will get a deep insight into what eigen decomposition is all about and how it works. Then I talk about SVDs, single value decompositions. This also, I feel that especially if you are into the topic of dimension reduction, vectors, vector space, natural language processing, then you should have a good idea about what is SVD. There's a very good Wikipedia page on single value decomposition, and it gives the mathematics behind it, but it is a bit hairy. It's a bit difficult to follow. So if you're not really into too much of mathematics, then you can skip the finer details and try to read my book, which tries to cover it from a slightly more, broader perspective with less mathematics, right? This is the SVD example. This is, I'll skip this. Yeah, this is SVD for dimension reduction. And why should you do dimension reduction? Also, I've tried to explain in the book. In my book, I've tried to give an example of. In fact, I've taken an example of readers who follow books. The book that for example, suppose you have a data of people who read different types of books, and then when you see that data, you find that certain people are reading books on arts, certain books are reading books of science. But this art and science is something which we have categorized. Suppose your machine doesn't know the term art and science, it just sees the readers. Maybe by analyzing the data, it can come out with the conclusion that there's a type of book which it may call X, but which may correspond to science. It may come out with another type of book category called Y, which may correspond with arts. It may come out with another category of book, say Z, which categorizes which coincides with economics. So what your machine learning algorithm has done, seeing the data, it has tried to classify or label the data into distinct categories or distinct bins. This is what machine learning is all about, and how you can use eigen decomposition and single value decomposition for these kind of tasks. I have explained, I think, in a fairly good way in my book. Have a look at it. You might, it might help you, right? These okay. Now come to pandas. Now, pandas another great library. In fact, in my book, I have tried to cover certain advanced topics. For example, using pandas for getting data from Excel sheets, and all those things. A lot of data is there. A lot of material has been covered. So if you know pandas, you can and you have to do a research project where your data is in the form of a table or an Excel sheet or an online web page. You can easily use pandas for all doing all those things, right? So pandas I'll skip. Then let me come to the next topic. Pandas is something called data frames. Now, data frames is something which is the most important concept in pandas, and I've tried to explain it in my book with a number of examples. Have a look at it, and I think it should help you. Then all these topics I am skipping, and then creating data frame objects from dictionaries, from lists, from embedded lists, all these things from tables. So these are the things which are there, and I'll just move ahead. Reading HTML, reading JSON files. Okay, now I come to this open source software and the types of licenses. Again, because the time is running short, you can read it. The types of open source licenses which are available. I think anybody. In fact, I've written about this book. The Cathedral and the Bazaar. I like to talk about this. It's a very interesting book, and I think anybody who is into computer science should actually read this book. This book says, I'll give you very briefly. It says that there are two ways of constructing a building, right? The first is what is called a cathedral, other is what is called a bazaar. Now, cathedral, how do you make a cathedral, or how do you make cathedral can be, say, a church or a very elaborate building. You design the whole thing, then you pre-plan everything, then you make it. That's the way a cathedral is built. The bazaar, on the other hand, a common heart bazaar doesn't work like that. So there's somebody who wants to sell potatoes, so he starts selling potatoes, and somebody else who starts selling, something else. Then a third person comes along and he finds that with potatoes you need onions also, so he starts selling onions like that. So the bazaar builds up as a need of the day. This is the difference between the open source software and a proprietary software. If you have a software like Windows, if you have a software like of MS Office, they are the cathedrals. But if you have a software like Linux, the Linux is the best example of an open source system where somebody developed a small core program, put it on the net, somebody added something else, and somebody added something else, and it became a bazaar, right? So read this book; it's available. Then there's another book, "Free as in Freedom" by Richard Stallman, who is the father of open source movement. And another interesting story about an Indian story is about Calibre, right? Which is written by an Indian called Kovid Goel. It's a very famous open source software, and read about that. If you want to read, you can read about that. Yeah. This is another. These are two topics which are there in that online part of my book. That means it's totally free. Read GenSim is a great library for topic modeling. The book is this chapter is available on GitHub. You don't have to buy the book to read this chapter. Just download it. It's full of examples and vector space models. So I can't discuss a vector space model in this short period of 45 minutes, but I've tried to explain this vector space model in the book online portion as an appendix. So there's an appendix called Appendix 4, which talks about vector space models. So I think if you are into natural language processing, if you are into, for example, let me suppose you have all the words in the language in the form of vectors of, say, 1,000 dimensions or maybe 5,000 dimensions. So then if you plot a vector for, say, a country like India and a country like Pakistan, right? Then these two vectors should have certain similarities. They might be pointing in the same direction in that 1000 dimension space. Based on that, you can actually do some very interesting, analysis that I've tried to explain in this book. I think I copied one of the diagrams here. Yeah, this is the n dimension space. I've tried to see this diagram I've copied from my book. So I've tried to explain that how by training you can bring one vector closer to another. I can't discuss it now. Have a look at it. Then GenSim I have discussed. Then open source. I think GitHub I mentioned. So GitHub basics. I can't discuss GitHub because that's not the topic, but I feel that it's an important tool. So Prakriti, I think I have run through the entire presentation. Maybe you can take over.
Thank you so much, sir. I think people have been asking for a specimen of your book all around the session, and they are very, very excited. I've already told them that here I would also like to announce, in fact, that we are sharing exclusively the ebook of Python Programming by Anurag Gupta and GP Biswas as an ebook on our platform Express Library, and you can access it till 2nd of
Okay.
January. Credentials to access it, the link where you can go use those credentials are also given in the registration confirmation email. So if you want to just go through the book, see what all is covered, the book is available on Express Library till 2nd of January for your review, right? Okay, sir. So very quickly moving on, I think we have
I just add one or two, Prakriti, very quickly before the
yeah.
question, I just like to add one or two things for the entire, all those who are with us today.
Sure, sir.
That
Sure.
uh, the book has 25 chapters. 20 are in the print form. 5 chapters are in the soft form. But these 20 chapters also, I have made extensive PowerPoint presentations which are available on my GitHub page, and I think they're available probably on the McGraw-Hill website also. So, if somebody wants to get a flavor of what the book is all about, and he doesn't want to spend whatever 500-600 rupees it costs to buy the book, you don't have to buy the book first shot. You have a look at those presentations, and if you think that these presentations are in the form of PPTs, PDF formats, all of them are available on my GitHub page. You can download them. You can do whatever you want to do with them. You can use them in whatever way. I have no issues with that. So just this is what I wanted to add. I'm done. So please say whatever you will say.
Okay. Thank you so much, sir. I think that was something that a lot of participants were waiting for you to say, that all information that you've provided is accessible on your GitHub page. So moving on to the questions. So one actually is around your book. So the person is Mr. Sachin Kumar Agarwal. They ask, is your book sufficient for a beginner to an advanced level, or is it specific to somebody who knows a particular skill set?
See, Prakriti, my book starts from the very basics. The only problem which somebody, which I find from experience, I find that one of the biggest problem which a beginner or a novice faces is installing the Python ecosystem. I have tried to explain that in the appendix of my book. So if you are able to go through that little bit of step of installing, because I think in India most people use Windows. So in Windows you have to do one additional step of you have to do a little bit of tweaking you have to do for running Python on your machine. So if you can install Python on your own in your machine, then my book will take you from the beginning right till the end. I mean, you can see the scripts which I have written. For example, one of my scripts which I wrote was giving the spread of. Can I just show it to you? Should I show that script? Would you like me to show you, or do we have time for that? Prakriti?
Sure, sir. I think we can spare another 3-4 minutes to quickly have a look, and then we can move ahead with
So
the question.
I just need to see how we share the screen, right? It is from chat, I think. Is it from chat? No. How do you share the screen, Prakriti? Just if you could just remind me again. I have forgotten. You told me, but I just seem to have forgotten. Hmm. Oh. Prakriti,
So
I've forgotten how to share the screen, so I think we'll skip that.
right below the next
I
button,
think
there's
we'll skip it. We'll skip it. We'll skip it. We'll skip it. The
sure.
script is there on my web page. It uses a library called Plotly, and you know what it does? It plots the what is called, if you have heard of a thing called choropleth maps. It does a choropleth map of the entire world where the color of the country is depending upon the number of cases it has, and it does an animation frame right from the month of March right till today, December. So you will see the colors of the countries changing as they become more or less infected. So that is one script I wrote for an online magazine, and it took about 30 to 40 lines of code only. And that kind of skill level I reached by writing my book, and I can assure you that anybody who reads my book and who's able to install Python on his own. If you have an issue with installing Python, or if you have an issue with installing Jupyter, send me an email. I would love to help you to doing that. But it is so easy that anybody can do it. And once you are installed Python, anybody can learn Python, whether you're a girl or a boy, whether you're a child or an adult, whether you're a computer scientist or a humanities student, you can learn. It's so easy. That's what I would like to say.
I'm sure, sir. I remember that during our last discussion, you had shown us that very beautiful map that showed, that I think was a heat map, in fact. And I remember that it's a beautiful script. So I'll ask all the participants to go to the link. We can definitely share the link with them in our, emails as well if required. Or we can give it to them with the webinar recording, and they can definitely visit and see it. So moving on to the next question, one of the participants asks, "Is Python more demanding than JavaScript?"
More demanding. You see, they are like two different ecosystems altogether. I think Python is much easier to learn than JavaScript because Python is very predictable. JavaScript is, for example, I can share a link of a video where if you can actually add a string to a number in JavaScript and not know what the answer would be. This Python doesn't allow that. So Python, I think, is a much better framework than JavaScript. But having said that, I must also say that the entire browser ecosystem runs on JavaScript. So if you really want to go the JavaScript way, then the better path for you would be to learn TypeScript, because I think Microsoft is promoting TypeScript in a big way. And the advantage of TypeScript is that it has the advantage of JavaScript without the free typing of JavaScript. So it does what is called typing. So you can say that TypeScript is a typed JavaScript. So if you want to go the JavaScript way, then probably TypeScript is a better idea. That's what I, but then I, this is my limited knowledge. You need to do some more research on this.
Great, sir. So one of them asks, "Sir, for machine learning algorithms, they can be implemented on a number of environments such as Python, R, Vika, SPSS, etc. Which one do you suggest is better?"
I would suggest Python. Uh, the reason could be that since I know Python so well, probably that's the reason. But there are some other reasons. The first is that
Sure, sir.
the entire world is moving on Python towards Python. So when you are in computer science, you don't look for unique things because that's nobody is studying and reading and writing about them. You need to follow the common things because everybody is talking about it, reading about it, writing about it. So if in 1,000 applications 999 are written in Python and one is written in something vague, then you would like to be with the crowd rather than with the. I think Python is the best. I mean, I can give now. MIT has moved to Python. Now MIT is supposed to Massachusetts Institute of Technology, the world leader in computer science. They have moved to Python. So even if you say that they are doing something good or something right, then also Python makes sense. That's what I would say.
Sounds good, sir. So, I think you've written a couple of articles on this as well, and I think it's very important for everyone to know. So, this one is a very relevant question. What is the role of artificial intelligence in this pandemic situation. So I think if we can break it down further, I think you've wrote a couple of questions on how programming, machine learning, Python have helped in the COVID situation. So maybe if we can take it that way.
Yeah, you see, ultimately, data is a king, right? Now, we are moving from machine learning to a different area, which is called big data. Now, I'll give an example. Now, many years back, when this big data analysis started being done, now the advantage of big data is that suppose you are a Google engineer and you know that all the searches which are happening in a place, and you want to know if a pandemic happened in a particular area. Suppose if malaria happened in a particular area, and suddenly you find that everybody is doing a search for a chloroquine on Google. So what conclusion would you draw? The conclusion you would draw probably is that since people in say a city like city X are searching for chloroquine, then probably malaria is spreading in city X. So that kind of insight you can get into a problem by using data. That I'm just giving an example. So this way, this is one example. Now, for example, I'll give another example. Now, in cyber crimes, so when many times you were trying to find out, for example, Delhi police once they tried to find out who did a number of blasts in four different locations. Now there was nothing common between them. There was no person who was seen. So what they did, they downloaded the tower dump of the mobile towers in these four locations and tried to find the common numbers. So suppose a blast one happened on day one, blast two happened on day two, blast three happened on day three, blast four happened on day four. So if you look at the dumps of all these four towers, and you find that some number is present in all the four, the tower dumps, then one conclusion which you can draw is that the person had visited all these four sites, maybe as a kind of a recce, or maybe on the actual day of the operation. They actually caught people like that. So if you have large amount of data at your disposal, then you can do a lot of insight into this thing. And it is not confined only to COVID. It can be for crime detection. It can be for fraud prevention. For example, credit card frauds. Most companies have algorithms. Suppose a credit card is used in the morning to buy some item from India, and in the evening, after a few hours, it is used to buy something in Africa. Somebody clones the data on the card, sends it to somebody in Africa. That fellow puts it on an empty card and then uses it to buy something. Then the algorithm can detect that it is not humanly possible for a person to be in Africa and India within a span of 2 hours. So that kind of fraud detection can happen. So the possibilities are limitless. Today on set, I was reading an article where the Prime Minister of India has flagged a driverless train in Delhi or something, right? So I mean, it's a great area with a lot of opportunity for youngsters, and machine learning is actually the future of computing.
So one last question
Yeah.
before we end the session, because I think this is related to the answer that you just gave. So while running a classification on a machine learning process, how big the data sample would be considered as a good sample? So this is a question by Sonika Gupta, and she also asks, let's say, for example, I get some classification result with some minimal data. Would increasing the data impact my results, or would it have a better opinion in front of others if we use more data, or would it make more sense?
See, I must be very frank. Number one, I'm not an expert on this, but in my talk, I talked about two things. That's called overfitting and underfitting, right? So if you have too much of data, then you have overfitting of the data. If you have less of data, you have underfitting of data. Both of them are a problem. So machine learning is not a pure science. It is also a form of an art, in the sense that everything doesn't work purely as per. Some things work by different hit and trial errors also. So that's the only answer I can say. I can say there is no universal, but there are some very good. There's a course on, I think, Coursera, I think, by Andrew Ng, and I think it's free of cost. So if you are going into machine learning, have a look at that course by Andrew Ng. It's a world famous course on machine learning and artificial intelligence and the concepts. And he has dealt with the topics in a very very non mathematical manner, which will give you an insight and maybe answer some of these questions which may be coming in the minds of youngsters. like the one you just mentioned.
Thank you so much, sir. I think this was an amazing session. We had a lot of questions, but I think we are more out of time. So if we do get a chance, we'll have another session with you and take up these questions. For now, sir, any parting words for the audience? Any parting words for the youngsters available with us who would really like to take up Python as a profession in the coming future?
Yeah, I would like to say two things. Number one, that my email ID is there as in my presentation. I would request you to share my presentation with all your participants. Put it on a link, public link, and make it available to everybody. Anybody who has any issue with Python, please you can send me an email. I will try to answer your question. I may not be able to answer all the questions, but I will try. And number two, machine learning. I think that our country really needs, if we have to become the world leaders in technology, then we need youngsters, people, young engineers who do such a great job if they work for companies like Facebook and Google. But if you know machine learning, maybe you can do your own startups. And if you can do your own startups, you can generate money, you can generate wealth, and you can create employment. So I would encourage all of you, all the youngsters, that have a look at the technologies, try to imbibe them, learn from companies, but at the end of the day, think of doing your own startups, your own companies, your own little contribution to our country's economy, and yeah, that's it.
Thank you so much, sir, for such a wonderful message. Thank you so much for joining us today for this wonderful session. To all our participants and our speaker, especially Anurag Gupta, sir, I think we've thoroughly enjoyed the session. It was really insightful. For all the attendees, we will be sending a recording of the session soon to your registered email IDs. We'll also be sending out the participation certificates to the same email ID because a lot of you are asking. So to access this ebook, you can use the link that is given in the email. You received an email for the confirmation of registering for this webinar. In the same email, you will find the detail of how to visit Express Library portal and what credentials to use to access this ebook on that portal. Additionally, if you still feel that you're unable to access the book, or if you find any other issues, please write back to us at support.india@mseducation.com. Thank you so much for joining us today. It's a pleasure, and thank you. And Happy New Year to all of you.
Yeah, and to you also, and you've been a great support, and to the entire
Thank you,
macro health
sir.
team. This is the first time I wrote a book, and I must tell you, got a great team on board. Your people drove me, so hard, and did such a good professional job. Thank you so much. But please, again, I'm repeating, please share my presentation with all the participants. Send them in the form of a link to all their emails so that they can read the entire thing. I could just cover about 20% of the presentation. It has about 60 odd slides, and I'm sure that they will really benefit from the presentation. That's it. I'm
We'll
done.
try to do our best, sir. And in fact, if we do, we'll keep you in loop so that if we can make a portal where you can communicate with these students and people who really want to learn, maybe we can connect you to them. Maybe on YouTube or somewhere, and we'll try to do our best. I think this was the last session of the year from McGraw-Hill, and I think we've ended it on a great term, learning something new and learning something about Python in a really upcoming field of machine learning. So thanks to you all for making this such a wonderful year and a great session. Thank you so much.
All right. Okay.